What is up, guys? I'm in my lair, actually up in the bedroom. Finally continuing the project that got sidelined for the Mustang. The LCD control, license plate flipper down, anti-theft system. So there's the breadboard, that I was working on before. But, it's turning into a mess. I'm like, there's just too much circuit on that. So... And I still had to add another relay to switch the polarity to the servo and everything. It just was getting cluttered. So, yeah, this is what I have to do. I haven't used this program in a while, so I had to reinstall it. This is not the cheapest, but it's a pretty good deal. This is Express PCB. This is their little software you could use free, and then once you're done, you could just order it. The circuit board have it etched and sent to you. So it's basically going to cost me about $50 plus shipping, about $60 to get the circuit board. On this deal, they actually send you 3 of these boards for that price. So I have 3 of the same thing. So I could build a new one and put it in my other vehicle. So just drop the same parts on there. So here's what I've been doing the last 2 days, or actually most of this today. But yesterday I ordered most of the Molex plugs. But so basically got the schematics that I have, my pin layout with my chicken scratch notes, where all the data connections to the LCD go, the LCD connector header, kind of lay this out in my head just by looking at these and like looking on here. And so basically I'm to the point now where I'm checking my circuit before I order it, because you'll find mistakes or find some traces that interconnect and whatnot. This is a dual-sided circuit board, so all the green traces are on the bottom. So I could take away the red. There you go. See, that's just the bottom of the circuit board. So it looks nice and neat. See that? And then put that back. Take away the bottom traces. That's just the top. So you can tell now that we're not getting any cross connects. You take away the masks too. It just shows where the parts are gonna be laid out. That's just for designing. There's the actual circuit board. So that's the top of it, and that's the bottom. Gets a little confusing when they're both on at once. So you have to, I review basically every pin. So I just got done reviewing this. So basically, there's pin 1, which I'm mapping it just like it goes down the line on the LCD here. And of course you skip 4 in the middle, but I just still count it 1 through 12. I got 6 here and then 6 up there. So basically there's some skipped. It shows 1 through 16, but it's really going to be 1 through 12. So 1, just show you how to do this. Basically, 1 is ground, 2 is 5 volts. And down at the other end, it's like, you got your positive and negative. So, see here that negative right here goes over, and connects to the negative rail here, which is going to go over to my 7805. All the negatives are connected right there. Positive, comes over from the 7805 over, hits the pick chip also, hits that pin. Positive goes down and jumpers down to that pin, because that's positive right there. The only other little trick it does is it doesn't just jump, negative don't just jump over here, negatives go down this transistor right here. Bring up the mask for that, you can see that a little better. So ground here, this pin here, pin 12, is going to go to here, and then to bias the gate of the transistor will be this output here on the chip, which if you look at my chicken scratch, the 4th pin from the end of pin 17, LCD backlight. That way the software can turn on the backlight. I do that so I can flash the backlight when the key is off. It goes blink, blink. How people have blinking security lights. Well, it blinks the LCD display. So if you're peeking in my car to look for the stereo or something stupid like that, you're not going to miss the blinking message that says something about warning about risk of death. And especially people now knowing that people can build bombs and stuff and all the news, and that's a side thing about the stupid bullcrap 50% lie news coverage. People will be afraid of stuff like that when people can make things, so they'll probably see that as custom and probably not going to mess with my car. And that's the whole point. I'd rather just people not mess with my stuff. That's why I put my security cameras out front of my house. Very blatant. People see it. And people see my cameras on the front of the house, and they leave. So, and I know people see them because I see people come in to do the door flyers or to come whatever, random people that show up to ring the doorbell. And I always, when I look back on the security pictures, I always see them at one point looking up at the camera. That's awesome. So Yeah, so people come to case my house, they do. If they case my car, I want them to go, I'm going to go to another one, because this guy might have a booby trap, which there might be a booby trap in my car. So anyway, I just got on that little tangent there. So that blinks it. So I go down the line, looking at all my pins, just showing you quickly how I'm going to do this. Can't do the whole board, it'd take forever. But pin 3, I look down there. Their schematic falsely says no connection, but really I found out on these, if you don't bias that pin a little bit, the contrast won't be bright. So there's a pot here, for the contrast that I can vary. And I implemented that on the circuit board here. It's just, you could adjust just a little under 5 volts, I think it is, or maybe it's just above the ground, I can't remember, but bias to that pin 3 if I take away the top one and the mask there. It's actually the 1, 2, 3. 1, 2, 3. Oh, look right there, I got a problem. It got a cross connect right there. See? That's the kind of problems that you have. And you've got to rethink all this out after you've laid it out, and you'll find mistakes. So what can I do? It's going to be a fun one, because I got a lot of stuff going on right there. I don't even know how that happened. Because this one, I've seen it before, and I was like, oh, that's fine. That's pin supposed to be grounded. Well, it's this pin that's supposed to be grounded. And I somehow accidentally went across it. It looks like, oh, you know what? So this will be an easy fix, I think. Actually, I can just go over here. So, do the... Okay. Get rid of that. Look at that. If I wouldn't have caught that and would have ordered this board, I would have caught it later. And I would have had to basically add a jumper, which would mess up my pretty board, and take the X-Acto knife and cut off that trace, to remove the short. Wouldn't have been a detrimental short to the whole circuit. It would have kept this pin at ground, and if I would have turned the pot all the way towards positive, it just would have smoked it at that point. So we're good now. It looks like that's good. So that's the kind of thing, see? Kind of mistake as I'm showing you how to do this. So that was pin 3. Pin 4, I look down and it's like my register select, pin 6. See, I have my notes, cross-reference, pin 6. My note, register select there. Yeah, the camera isn't flat focusing as fast as I'm doing that. So, pin, what did I say, pin 4, this goes to pin 6 on my chip. So 1, 2, 3, 4, I use the red. Going down over to pin 6. 1, 2, 3, 4, 5, 6. Going over there. You can look on red and red, there's no cross connects. It's a pretty straightforward trace. Really didn't need to be that thick. I could have used a 0.06 thickness, but no issues there. So, should be good. Now with both mask layers, you can see there's that one I redid a few minutes ago, so it's not crossing that trace because the green's on the bottom, the board red's on top. The only time they'll interconnect top to bottom is when you go across a pad, like a hole, through hole, there's a, pad there to solder and where the pins drop through. So, like right now this green is running across here. And, that looks bad. But actually that's supposed to be there. This pin is both connecting to over here for an input and down this pull down resistor here. And this pin also serves as the VPP. Let's see, on here. See pin 1 right here is VPP, which is going to be pin 4 on that chip. So VPP goes down here. That pin has more than one purpose. It's got the purpose of being my plate actuator switch, which is going to be on the dash, or whatever, to activate my flipper down plate. But during programming mode, it's also a VPP pin, so it has dual purposes. And then right here, I'll turn the mask back on, will be, a 6-pin plug. You just plug it in. Which will only be plugged in just when I'm updating the programming in my chip. Other than that, nothing will be plugged in that pin. This 12-pin header goes to the LCD. This 12 pin ties to everything in the car. It's going to be nice and neat. And the board is actually about, let's see, that size. So, about the size of the prototype. Maybe even a tad bit smaller. Here's a, yeah, I went one size down too far on the scale. That's probably about the real size. Yep. I can tell by holding this up to the screen. The relay here that it plugs in right there. Or if I hold up, like a 20-pin chip, you can see that it's just right with that. So that's real size right there. So it's going to be pretty compact. That's why everything's so close together. I'm just zooming in to do the traces. But yeah, when it's down like that, yeah, it's pretty compact. So it'll fit down underneath where that stock clock went in the Mustang there. Anyway, so that's basically how it goes. Each one of these pins, I further go down and look. Pin 5 just goes to ground. That's that green that goes up there. So that's fine. That's supposed to do that. And then 6 is the enable pin, which just goes over to pin 19. So it's just simple. It's just going from here to right here. That pin also double duty for the clocking for when you're programming. So, and here's where I ran into a problem where I couldn't avoid the upper or bottom traces. So this spot right here, I didn't put a mask for it, but this is going to be off to remember. This is a jumper. I'm going to have to jumper over to here, and this one's going to have to jump over here to go over these 2 pins. Take away the top mask. Let's let you go. These 2 pins go right here. Data, clock. Actually, I see I messed up. Nope. EPP ground. You know what? I see I made a mistake on that. See, I caught that. Now I got ground right. It's this pin that's supposed to be skipped, not this one. So see, there's another one. I was on the wrong spot. That's going to be an easy fix. Blam. Do the trace disconnect little deal in there. We're going to move it over here instead. Fixed. All right. Now 1, 2, 3, 4. The 4th pin on there. 1, 2, 3, 4 is clock. Going to go over here, hit this jumper, hit this pin, and then the red trace on top can take it over to this 2019 1876 pin 16. Oops, I'm looking at the wrong thing now. And my doorbell's ringing. Oh, I made a couple mistakes there. I could see I put these 2 pads in the wrong spot. That's why. So I just grab these objects and move them. Of course, it takes the trace with it. So I got to fix that one. See, so that's basically what you find. You just basically need to go through your pins and just follow where it goes, and you're going to find mistakes. And then once you're sure you didn't find mistakes, then you're ready to order it. And then you just pretty much go order boards on the internet, and you go through and basically do it. And it's this program's made by them, and you could put in your information, your shipping address, your credit card number. Bam! Give it a couple days. 3 of these circuit boards will show up. I've had them made before. Probably got maybe find one downstairs, show you what it looks like. So I'm going to go through now and basically continue on just by myself and going through and finding all the mistakes. And otherwise this will be an hour-long video. The other thing I did, just to show you real quick. So here's one of the parts I've ordered. 12-pin position. Looks like a Molex connector. It's made by another brand. But you see these like, this is a right angle one, but you see these on train circuit boards. They're mounted in there, and then you have a female piece that goes with this. That's that, with all the wires connected to it, and then like you pull it up off, you can switch your circuit board, and you plug that on, the circuit board onto those connectors like that, So you have that, and then the thing you have to be careful. You have to go down and look at the associated products. That it'll mate up some of the connectors, but this little these pins here, they don't come included with these, so you got to be careful. You order just the the part that goes on the circuit board and then this wiring harness part, you don't have everything you need. You got to have these. So you got to buy each of these separate. These you crimp the wire on and then solder them, and then you need 12, for example, you know, for the 12-pin one. So I buy 250 of them at once for $9. I bought 10 of these at once for $5, you know, and 10 of these at once for $5 basically. And I bought a bunch of assortment. Got on order, you know, 10 of those, 250 of the pins, and then I stayed to the same kind of brand for getting the 6-pin ones, the 3-pin ones, the 5-pin ones, and they all use the same pin. So 250 of those little metal solder-on pins will last me a while. Make mistakes, whatever. Need to rip one out, cut it off because I got the wire in the wrong spot, or a different wire could do it. So, and basically those will all be these two things here. So my whole basically take this thing and all the cars and the wires in the car. We'll make a harness. Go to those 12 pins right there, and they'll just plug into that part that's the connector that's going to be on the board right here, 12-pin connector. So, and then of course I got my other parts, the voltage regulator, RZ44, MOSFET. That's going to pulse width modulating output to the license plate servo. I like to use pulse width modulation so I can tune how hard I'm going to drive that servo. You just slam a relay to like throw 12 volts to it. I mean, you're slamming those things pretty hard, and I don't want to start stripping out the worm gears or whatnot. So I like to do pulse width modulation so I can tune how much power it really needs, and in the logic I can make it like do a full power but then ramp the power down, you know, do holding power, so to maybe hold the motor in this position, but it won't be full power, you know, killing it, heating it up, you know, stuff like that. So I'm going to go through now and fix those mistakes I just discovered, and then make sure it's I got everything there, and then I'm going to order this. Okay, I just spent about 30 minutes playing with this. I did find a couple more problems. I had a couple interconnects. You said the green's are the bottom trace and the red's the upper. So when they crisscross like this, it's fine, because as long as they don't go across the pad, you know, they're on two different sides of the board. But like right here, this trace went over here and then up to over here. And it went right across the pad. I was like, didn't even realize that. You know, take away the red. So I just had to move it up. It was going right here. It went right across this one. And when you're only working on one trace, like you take away everything, right, it wouldn't look like a big deal, but I'm going across that pad and went up right there. Well, you bring the other side up, wait, you know, that pad goes over here, you know, and that pad's going to this resistor that's taking this circuit over to here, you know. So, of course, when I get my circuit board, because I'm not going to pay the $20 to have the masks, it's going to look like that. If I pay $20 more, it'd have those outlines on it once it was done, so you can see where the components go. I'll just have to look at this and look at my board and know this resistor goes here, this one here, this one here, this one here. Those are resistors. You know, this is a transistor. This is a transistor. You know, stuff like that. This will be a big hefty pad they put in there. That's for where my a voltage regulator and stuff goes. You know, just it's being cheap. You know, like I said, if I paid extra $20, they would come back. They would have the mask for all the components silk screened on a circuit board. It shows you where everything goes. So, yeah. And I beefed up these traces here. These go to the two output pins that are connected to this relay right here. See it very well. It relay goes on the board, and that's the relay that switches the polarity when you're going to pull the servo the other direction. So that's all beefed up, and all beefed up to the MOSFET. Heftier traces. Of course, when you go to the real size, you know, they don't look as big. You know, but that'll be about right. That's real actual size right there. So, of this circuit board. So it's pretty, yeah, it's pretty packed. There's more parts on there, you know, that I got on there because I don't have I got a 12-pin header over here, a 12-pin header there, 6-pin header there. The other this relay that's not on this board yet, you know, it's going to go on there, you know. It's actually laid out a little different now on here. You get the big reversing relay here, and then the fuel cut relay, which is this little blue one there, you know, that's up at the top. I think it's done. I've pretty much followed all the pins. Been going pin 1's power, pin 2 is ground. I've been lifting the masks, the layers. Pin 3, you know, over to this relay. That's the output to go to kill the engine for theft. And then there's 2 buttons and a switch input. So this button goes over there. Bottom trace takes it to a pull down resistor. Button 2, pull down resistor. Switch, you know, it's like a button input, you know, goes over, pull down resistor. This one here is the status coming back. So all of it looks good. This one's actually an extra pin. I put a pad on the circuit board just because later on I want to use that for something. I can add a jumper or something. Hopefully I won't have to. I'm trying to keep, hopefully this will look all perfect. And see this one. 1, 2, 3. Where does that go to? Oh, it's just, yeah, just a little trace. That's a sample, because this power is on all the time right here. That's 12 volts continuous from the battery. This one here goes over to tell my chip. It's got to go through this voltage divider. It'll be a, you know, high ohm resistor, like 100K or something, and a 4.7 volt Zener diode. That basically current limiting here, and then a Zener diode will clamp down the voltage to 4.7, so it won't be 12 volts or more. You know, and driving it at 14 volts, you know, it'll be 5 volts or 4.7 going to the input. That'll be a logical one into the microprocessor, telling it the status, the key is on, basically, because that's a different mode. So that's what that is. And then, like I said, I already said what these 2 were. So pretty much, I just traced all these out, looked where all these went, looked where all those went. I added a diode just in case I want to power the chip off of the programmer. But the diodes are to prevent backfeeding into the programmer if I have power also coming from the car, you know. So I've done that before. Everything looks pretty good. I think I'm about ready to finalize this and order it so I can get this to come in, so I can maybe get this together by next weekend. So anyway, back on track with this project. And I'll put an update once I get all the parts and start putting it together.